Hey everybody, Mr. Dickman here. We're going to continue with some conditional probability, and we're going to talk about this in the context of two-way tables. Okay? So two-way tables are great problems because they give you a lot of information, and then they can ask you a conditional probability. They can ask you a probability with an or in it. They could ask you just a regular old probability, and you have to know from all that information what the answer is going to be. So first we're going to start with this warm-up, and so I want you to complete the warm-up, hit pause and do the warm-up. You can hit pause now, and when you come back we'll go over the answer. Alright, so a card is picked from a standard deck of cards. We want to know how many different outcomes are there. Well, in a standard deck of cards there are 52 cards, so there are 52 outcomes that we could have. What is the probability of picking a jack or a spade? Well, if we pick one card from the deck, the probability of picking a jack is there's 4 of those in the deck. There are 13 spades, and there's one card that is both a jack and a spade out of the 52 different outcomes. And so this is very much the same probability as we had with the ace of hearts the other day. And so that is going to be 4 plus 13, which is 17, minus 1 is 16 over 52. Divide by 2, we get 8 over 26. Divide by 2, we get 4 over 13. So that is the probability of picking a jack or spades. And again, that comes out to 0.308 or 30.8%. These are all valid answers. Okay, so again, our goal for today is to talk about two-way tables. And what is a two-way table? Well, here's an example of a two-way table. So we have students in a college statistics class wanted to find out how common it is for young adults to have their ears pierced. They recorded data on 2 variables for all 178 people in the class. So here's our two-way table. Notice that we have different columns that mean different things. So if we're in this row, that means we have our ears pierced. If we're in this row, that means we do not have our ears pierced. If we're in this row, we are female. Sorry, if we're in that column. If we're in this column, we're male. Okay, and then we have our totals. We have our totals both for having the ears pierced or not, and that gives me 178 people. And then we have our totals also for whether or not we are male or female. Okay, so there's a lot of information in this table. So we want to know, what is the probability that a randomly chosen student is male or has their ears pierced? So we're looking for the probability that a student is male or has the ears pierced. Okay, let's just call that P for short. So that's going to be the probability that they're male plus the probability that the ears are pierced minus the probability that they're male and the ears are pierced. So that's our addition rule that we talked about the other day. These are not mutually exclusive events. You can be both male and have your ears pierced. You can be both female and have your ears pierced. Okay? And so the probability that they're male, I'm just going to count up all the males. So all the males are 103. Oh, nope, sorry. That's the total number that have their ears pierced. The total number of males are 90. The total number of people with their ears pierced, that's the 103. But I did count males that have their ears pierced twice here, so I have to subtract out the 19 students who are male and have their ears pierced. And that's going to be divided by the total number of students. I had 178 different students I could have chosen from. I randomly chose a student from that group. So that's 193, which would be bigger than 178. But when we minus the 19, that gives me 174 out of the 178. And that's a pretty high percentage. So there is a 0.978 proportion here that I'm going to pick someone who is male or has their ears pierced, which is 97.8%. So let's look at the same exact data, but do a different question. What is the probability that a randomly chosen student is male, given that his ears are pierced? Okay, so we already know that the student has their ear pierced. Okay, so people that have their ears pierced, this is now the total number of people that I'm choosing from. Because if it's given that the person has their ear pierced, then there's only 103 people in this class that fit that criteria. Out of that 103 people, how many of them are male? So the probability that I choose a male student, given that the ears are pierced, is going to be 19, because there are 19 males that have their ears pierced, out of the 103 people that have their ears pierced. We can only, for this problem, we can only draw from this column because it's given that the ears are pierced. So my sample size, or my population size, has decreased because now the population is given to be 103. And so, still got my highlighter on there. So if we do 19 divided by 103, the probability that I'm going to randomly choose a student from the group of people who have their ears pierced that is male is going to be 0.184, or 18.4%. There are many more females than males that have their ears pierced, so it's less likely that I'm randomly going to choose a male student if I'm only choosing from the students that have their ears pierced. Okay, again, with all these videos, you can replay them if you need to. Let's go on to the last one. So now we're given that the student is female. What is the probability that her ears are not pierced? All right, so again, given that we're female, we can only look at this column now. This is the column that we're interested in. So we're given that the student is female, so I only have 88 students to choose from. So I'm going to pick from those 88 students that are female, and I want to know what's the probability that I get someone that does not have their ears pierced? Well, there's only 4 students that don't have their ears pierced. So that's 4 out of 88. If I divide by 4, I get 1 out of 22, which is a 0.045 proportion, or 4.5%. So these would all be acceptable answers. This is the probability that I'm going to choose a female whose ears are not pierced, given that I'm choosing a female. Okay?